Hello everyone, welcome to my channel. Today I'm gonna teach you how to calculate a truss. Sorry for the background noise that probably you're gonna listen during the video. I'm doing it close to the street. Okay, so we're gonna start Staad Pro. We're gonna create a new project. We're gonna select plane because it's a plane structure. We're gonna name it Truss 1. We're gonna leave the length units in meters and the force units in kilonewtons. So we do this easily selecting the open structure wizard, but I'm gonna teach you how to construct or build a model from scratch instead of selecting the wizard, because, well, you're gonna learn more doing it this way. So we're gonna select add beam. This is gonna be a beam structure base, and this is the structure that we're gonna to do the model. And well, we're gonna try to adapt this model into Staad, and afterwards check if the results are the same with a Staad or with a hand calculation. Okay, so first we're gonna define the mesh of the grid that we're gonna be using for this model. So we're gonna use the default grid, but we're gonna modify it. So we're gonna click it, edit, and we're gonna establish the grid now. So it's gonna be 4 base, 6 meters each one, and just a height of 1 meter, a height no 1 bay, and a space in between 3 meters. So this is enough to define our structure. So let's click on OK. Now we have this grid, and now we're going to draw the beams. This is really easy. So we're going to draw a single beam here with the snap node beam selected again, because we don't know. Well, I could have started from here and then continue, but it doesn't matter really. So we go from here to here, and then the other one. We click again in snap node beam to stop editing this beam, because now we want to draw this one, this here to here again, the other one, and the other one. So now if we click here, we can see it like with this view. It's easy to check this draw with the other one. Now the only beams left are the crosses, so we're gonna create them like this, and then this one and this one, and that's it. Now we have the model created, so we can close this grid editor. Now what we're gonna do now is check. We want to see how Staad has named all the beams and the nodes. So we're gonna go to this icon, symbols and labels. We're gonna select node numbers and member number. Apply, accept, and member number now. Beam number. Apply. So now, as you can check, as we have created this model like really like random, we draw this beam, and then we start from here to here. Now the numbering is quite messy, so we want to modify this to make to be able to check the model afterwards more easily, or easier, sorry. So we're going to select all beams. You can do this like I just have done with the beam cursor selected, but you can do it more standard, in a standard way. That's select by all beams, and you do the same, but no, this is a better way to do it. So now what we're gonna do is change the numbers to renumber all the members, and we're gonna, now it says that, well, this is better to do at the beginning. Don't wait till you have the whole model built to rename everything, because, well, it can change your results. If you have done the model, then you have done an analysis, and then you took some notes, and then you want to do it again because you have realized that it was difficult to understand the results because the numbering was messy. Well, the results are going to change, and it's not a good way to do it. So just keep it this way, construct the model with the grid, and then rename it as you want. So yes, we want to proceed, and I'm gonna rename this, giving priority to X and then Y. So if I click accept, now you can see it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. Now it's a little bit more easy to understand. So you can play with that if you want to sort it from ascending, descending, from this way, the other way, X. Now we're going to do the same with the nodes, because as you can see, it's like 1, 3, 5, 7. Not good afterwards to be able to understand the results. So we're going to again to select by all nodes. So you can see now the nodes are selected, and we're going to do the same. Renumber. Now we have to select nodes. Want to proceed? Yes. X. Accept. And now you can see 1, 2, 3, 4, 5, 6, 7, 8. Now it's easier to understand it this way, the structure. So now we're going to define the cross sections of the structure. So we're going to click here in property page. We're going to use the section database that was already included in Staad. I'm going to go to the Spanish cross sections, but it doesn't matter, you can select whatever you want. And I'm going to select IP300, select add. I'm going to select the IP180 and node channel. This one. And I'm going to use UPN. This is like a U section, cross section, but I'm gonna use it as if it was a tube. So it's gonna be like one U in this way and then another U in the opposite way to make a tube. So I'm gonna select double channel front to front. So they're gonna be one U like this and one U like this. I can select double channel back to back, and it's gonna be like the U like this and the other U like this, making like a H. But no, this is gonna be like a front to front. And I click add, close it, and now I'm gonna assign the cross sections to the structure. So I'm gonna use this IP300. I'm gonna select use cursor to assign. So I click assign, I select this and this. this is gonna have the same cross section. Now the IPE 180, it's gonna be here, 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 and then and here, here, and here. And now the tube sections are gonna be in the crosses. So I'm gonna select this, I'm gonna select this one, this one, this one, this one, and that's it. Close. Now to be sure that we have done everything right, well, you can check here the property reference that it's assigned to this beam, but it's easy and a little bit visual to select this option, and you can see a 3D render view. So this is what I have done. This is the IP, so double T with these are the tubes, the red, whoops, stop. Where you have done? What have you done here? Well, you can rotate, you can do whatever you want here. But yes, I want to save this. The autosave mode, it's selected, so it's gonna bother me a couple of times. So as you can see, this is the tube that we have built, and then the other cross sections. Okay, so let's select this, like this, and well, it works. Now we have checked that everything is all right. Now we're gonna define the supports. So we click here, support page, and we're gonna create one pin support. We click on add, and then we're gonna create another support. It's gonna be fixed, but we're gonna release the moments and the displacement in the X axis. Okay, so we're gonna add it, and now we're gonna assign it as we have done with the cross section. So we're gonna select support, use cursor to assign, and this node, and the other support is going to be assigned into this other support. That's it. So we're almost done. We are almost done. Well, not yet. Now we're gonna define the loads that are gonna be affecting this truss. So we're gonna click here, load page. We are going to go to load cases details. We're going to add one. It doesn't matter the name. I'm going to leave the one that appears by default. Add, close. Now clicking in load case, we're going to define the loads. It's going to be like it's add, and as it's going to be a member load, because we're going to load the beam. We're going to define the load. It's minus, because we want the load to be applied from top to bottom, not the opposite way. So it's minus 50. Add, we close this, and now that we have the load here created, now we have to assign it. So we click on assign, and we're going to assign the load, and this. And now we can close this window. Now the load has disappeared, but it's still there. So the thing is that we cannot see it. So if you click here in loads, you're able to see the load supply, but you don't have the value. So we want to see the value that it's applied here. So we're gonna click here in symbols and labels, and we're gonna check this load values. Apply, accept, and now it helps to see what's happening. So we are done. We can do something else. Before analyze the model, we have to say that we're gonna do analysis. So we go to commands, analysis, perform analysis. load data, or we can go to load data or static load because nothing's moving, so static load's okay. Okay, now we can do two things. We can go to analyze, run analysis, and this is what we're gonna do now. We're gonna modify it later because I want to do some changes. It should go pretty quick. Everything, zero errors, zero warning, so it's okay. Done. To see the results, we have to click here. Now it's available, this icon here, so we click it. As we only have this load case, so it's accept. And now what you have here, the displacement of the structure. Here you have the displacement in millimeters of the nodes, and down here you have the displacement of different sections of the beam. So here you have beam 1, this one. Let's check beam 2. It's this one. So here you have what's the displacement. And now we can do several checks. We are gonna go to beam graphs because I want to check the manual calculations with the results. So this is what Staad give us for the beam number 2, and this is what the manual calculations give us. So we can say that it's pretty accurate, right? A couple of difference, but yes, it seems okay. The bending moment, it's okay. These forces are okay. They more or less match with the manual calculations. So let's check another beam. So we're gonna check. Let's see if this one, number 4. So again it's pretty accurate. It matches the results that provide the manual calculations. But now we're gonna go to somewhere else. We're gonna check this member. And you can see a really big difference with the manual calculation. That gives us a result that this piece of truss has moments. And it shouldn't be like this because a truss has its nodes like free. So it should, this part should be able to rotate. So if they can rotate, they shouldn't have any moment. So we made a mistake. That's the thing. This is what I wanted to arrive. We have defined the model wrong, and this is why you have to check the results of your model, because it seems that yes, looks okay, lots of graphics, perfect, it seems like everything's okay, but you have to double check that what the results match with your design. So if you're designing a truss, you have to know that this shouldn't appear any moments here, and as you can see, there are moments. So we're gonna have to modify the model. So we're gonna go back to modeling. We're going to select, double click this bar, and now we're gonna change the releases. Now we're gonna release at the beginning of the bar the moments. Now it says that, of course, now I have the conditions of the bars, the results are no longer valid, so okay. And the end, we're gonna release the end, because you can release one end or another. Now check that it has appeared this little circle here that tells you that you have released moments, depending moments. So we're gonna do, well, I have done this already, this one already, not the end. And we're gonna do the same with this one, this, and I missed the other one, so close, the other one. So let's release the end. Okay, so now this is what we wanted at the beginning. This is a truss. Now we're gonna do something else. We're gonna add some design check. We're gonna check if this design with the cross section that we have assigned to the bars, it's correct. So we're gonna check with the Eurocode 3. This is a Eurocode 3. And we're gonna just check code. We could select that Staad optimizes the structure, so it to change the structure to match or to make the structure like correct, compare or check with the Eurocode. So now we're going to select everything, all the beams. We select, well, select check code by all the beams, and now we say assign to selected beams. If you don't do that, Staad is not going to make this check. You have to tell the program what you want to check, because maybe you just want to check one bar because you know that this bar it's problematic or whatever, but you just want to check this. I want to check all the structure. So now with this done, we're gonna go back again to run analysis. Yes, I want to save. For warnings, yes, for warnings. Now we're gonna check what these warnings mean afterwards. Now we're gonna do the same. We're gonna check the results. Okay, beam graphs, and we're gonna select this truss. Now it's okay. As you can see, it doesn't appear any bending moments, as it should be in any of these crosses, diagonals. So it's okay. So now if we check with the manual results, now we can be pretty sure that this model it's accurate with the model that we wanted to design at the beginning. So please double check the results. Don't get fooled because of the colors and everything, because you have to double check. You want to obtain the results that you want, not that the Staad provides you. So another thing, now we're gonna go to the warnings, what those warnings meant. So we're gonna go to Staad output, and we're gonna be able to check, well, the file as it is built in Staad. You can modify this as a text file, so it's when you know how to do it, it's really easier than to open the program and do it graphically. So yes, learn how to modify the files. Probably in another video I'll teach you how to build a model from scratch just using the file. So we're gonna go to the warnings. So if we go, but there's a lot of information here, but we're gonna go to the warnings that appear here. As you can see here, when Staad has checked if our structure was correct against the Eurocode, it fails. It tells you this is it's failing because of the tension. It's bigger than what that section can resist. So we should change it. We can do it in two different ways. We can change it manually and be checking, like, okay, we can increase the the size of the section, or we can leave Staad to do it, as I said before. When you're selecting the design, which code you're gonna use, you can tell Staad to design for you. You can tell Staad if something's failing, just change the section till it is correct. But again, I don't know if to recommend that. Well, I will recommend that if you know what you want. So if you really know that changing this IPE 180 to IPE 220, this should be okay, just let Staad to do it. And if the result it's more or less what you were expecting, it's okay. But don't do it that way, like automate everything and then say, okay, Staad is saying this, that this is well done, so I'm gonna believe it. I won't recommend it to do this that way. So, well, this is the end of the video. I hope you have enjoyed. I hope you have learned a couple of things, and I will continue with the videos. So see you later.